Hello, welcome back to the City High Science channel. Today, we will be talking about a catastrophic concept related to gas leaks. The explosive range. The explosive range, also known as the flammable range, is the range of the concentration of gases in the air in which an ignition source can produce a sustained combustion reaction. As such, gases have a lower explosive limit and an upper explosive limit that defines the range of combustibility, as gases will only ignite within a specific concentration range. First, we need to define the lower and upper explosive limits. The lower explosive limit is the minimum concentration of a flammable substance in the air that is required to support combustion, while the upper explosive limit represents the upper boundary beyond which the fuel-to-air mixture becomes too high to sustain a fire or an explosion. You also need to note that gases have an optimal mixture. This is the ideal concentration of a flammable gas in the air that can sustain a combustion reaction most efficiently. The optimal mixture typically lies within the explosive range, between the lower explosive limit and the upper explosive limit. Let us take methane for example. Methane can be commonly found in just sewers. And if you remember the explosive range, the sewers can provide the ideal conditions for high gas concentrations, as poorly ventilated areas accumulate gases over time. In this case, methane has a lower explosive limit of 5% and an upper explosive limit of 15%, which means that in a given volume, if the concentration of methane gas is 5% in proportion to the volume of the air, this 5% of methane concentration is the lowest possible explosive limit to cause a combustion reaction. However, if the concentration of methane is 15% in proportion to the volume of the air, this concentration is too high to cause an explosion. Methane is composed of one carbon atom, which is then bonded to 4 hydrogen atoms. As such, methane in the form of a gas can become very explosive under certain conditions. Now, you must remember this illustration very carefully. In relation to the image, methane is a fuel source, while oxygen acts as the oxidizing agent. Given a sufficient amount of oxygen, methane will undergo a combustion reaction if ignited with an ignition source. During the combustion process, the carbon and hydrogen bonds of methane are broken down, wherein carbon combines with oxygen to form carbon dioxide, and on the other hand, the hydrogen atoms of methane combine with oxygen to form water, where 2 molecules of water are produced in this reaction. This highly exothermic reaction causes an explosion, as it involves the separation of strong hydrogen and carbon bonds and the formation of new carbon-oxygen and hydrogen-oxygen bonds. This rearrangement of atoms releases energy in the form of heat, hence the explosion. This is the importance of monitoring gas levels within a given area, for example, a kitchen. In the kitchen, propane is highly flammable gas, commonly used for heating, cooking, and fueling various appliances, wherein a gas leak can cause an explosion followed by a secondary fire. However, this can be mitigated with proper handling of the propane tank and active monitoring of gases using LEL meters. Monitoring gas levels can be used as a security measure that ensures the safe handling and storage of propane, which can help minimize the risk of an accident. Now let's take a look at what these gas explosions can do.
Patrick, the temperature's the lowest we've ever had for a launch. Did you manage to run a quality check on the O-ring seals around the right SRB?
No.